Hello friends, welcome to Learner's Planet. Friends, I'm here again with one more session of permutation and combination. In the last session, we discussed some good problems based on integral solution, that is positive integral solutions and non-negative integral solutions for a given equation, right? So I hope you might have enjoyed the session. Now let's take some new problems, new concepts, new applications of permutation and combinations in this session. So let's begin the session. Now friends, let's take this problem. The number of ways in which we can choose two positive integers from 1 to 100 such that their product is multiple of 3, right? Now from 1 to 100 there are 100 by 3, that is 33 point something. So in all there are 33 numbers which are multiple of 3, right? See, if we want the product to be multiple of 3, at least one number should be multiple of 3. Suppose we choose two numbers, that is A and B. If one of them, at least one of them is multiple of 3, then only the product of A and B will be multiple of 3, right? So how do we approach the problem? What I do is, see, there are 33 multiple numbers are multiple of 3 and 67 numbers are non-multiple of 3. So what we can do over here, see, we can choose two numbers from 100. So that's in 100, see, two ways, right? Now these two numbers are suppose A and B. So we are choosing two numbers from 100. So we will be getting these many combinations. From these combinations, if we deduct the combination that we are getting from combining or choosing the two numbers from these 67 numbers, right? Because all these 67 numbers, none of the numbers are multiple of 3. So if we want to be getting the product that is multiple of 3, right? So I deduct all the combinations of two numbers that are formed by these 67 numbers, right? So in all this is like combination of two numbers from all the 100 numbers. This is the combination of two numbers from the 67 numbers which are not at all multiple of 3. So in the remaining combination, at least one number will be multiple of 3, at least one, right? So this is the total number of ways, and but we cannot calculate it because the calculation is too big. So the answer will be in this form only, that is 100C2 minus 67C2. I hope you are clear. Now let's see this question. There are 15 points in a plane, no 3 of which are in a straight line except 6, all of which are in a straight line. The numbers of straight line which can be drawn by joining them. Now we have already discussed that it takes 2 points to make one straight line, right? So what we have to do, we have to make all the combination of 2 points selected from these 15 points. So the total number of combinations are 15C2, right? But the 6 points are in a straight line, right? So we want to be getting 6C2 lines by combining these points. Why? Because all of them are on a straight line. Suppose I match these two and I match this two. So the line that I got from matching these 2 points will be hidden behind this line, right? So precisely this is just one line only. Similarly, if I join all the points, I'll be getting one line. So all the lines by combining other points will be hidden under this the complete line, right? So what I have to do, I need to deduct all the combinations formed by these 6 points. So I deducted 6C2, right? Now what is the next thing? So when I deducted all the combinations of 2 points from these 6 points, I deducted the combination of this point and this point also, right? Because all the combinations are deducted. But I'll be getting one line by combining these 2 points, right? So I need to add further 1. right? So what's the complete answer? That is 15C2 minus 6C2 plus 1. That is 15C2 minus 6C2 plus 1. I hope you are clear. Now friends, I have an interesting problem with me over here. Our parallelogram is cut by two sets of M lines parallel to the sides. The number of parallelogram thus formed is. Now friends, to make the problem easier, what I can do is I can take some comfortable value of M, right? So let's take the value of M as 3. You can take any value, but I'm just taking 3, right? That means I have drawn 3 lines parallel to the sides, that is parallel to both the sides. I just draw that. So this is the situation, right? So now it's very easy for anybody to say the number of parallelograms. This is 1, 2, 3, 4, 4 into 4, that is 16 parallelograms will be formed, right? That's very easy to say, and that's definitely there in the options also. Bright chances are that will be in options. Maybe here it is not there or not, I can't say. Now what's the mistake that we are making by calculating just 4 into 4, 16 parallelograms? What I'm doing over here, I'm just calculating the small parallelograms. These are formed, right? But just see this. This is also a parallelogram. Similarly, this is also a parallelogram, right? So we cannot make the various parallelogram and keep on counting, right? There should be some logic behind that. Now what that logic is, just listen to me carefully over here once again. See, to form a parallelogram, we need 2 points from this line and 2 points from this line, right? Now how many points are there on this line? This is 1, 2, 3, 4, 5. And how many points are there on this line? It's 1, 2, 3, 4, 5, right? If I select 2 points from this line, suppose I just change the color of the pen, wait a moment. Suppose I select these 2 points from this line and maybe these 2 points from this line, right? Now if I draw the line from these points, something like this, right? And from these 2 points, I'm sorry, I'm not able to draw a straight line, right? So what I get a parallelogram over here, that is this parallelogram, right? It's A, B, C, D. I hope you can see. So this is A, B, C, D, one parallelogram we can see, right? So if we choose all the combination of 2 points from this line and this line, we'll be getting all the number of parallelograms that are being formed from these points, right? So what I have to do, it's 1, 2, 3, 4, 5. I need to select 2 points from this line, and simultaneously I have to select 2 points from this line. So it's further 5C2. Now 5C2 is what? 10 into this 10, that is 100. So how many parallelograms I'll be getting? That is 100 parallelograms I'll be getting. Okay. Now when M was 3, my answer is 100. Now you can use the options. You just put the value of M in the options, and wherever you are getting the answer as 100, that will be your correct choice. So this is obviously not the correct choice. Here 3 plus 2, 5 square, that is 25 by 4. This is not correct. Similarly 3 plus 1, 4 square by 4. That's also not correct. Obviously this is correct because it is the last option. We just put the value. M is equal to 3. So 3 plus 2, 5 square, that is 25, into 3 plus 1, that is 4 square, that is 4 into 4 by 4. So it's 100, right? So when M is equal to 3, the answer is 100. So we put the value of M as 3 and got the correct choice, right? I take one more problem like this, so the concept will be cleared in your mind once for all. Now friends, suppose I have this rectangle or maybe this parallelogram, whatever you can say, and I divide this rectangle or parallelogram or I draw some parallel lines over here. Maybe I draw one line parallel to this side and two lines parallel to this side. Let's see what happens. So I have drawn one line parallel to this. I just name it. It's A, B, C and D. I draw a line parallel to AB and CD and draw two lines parallel to AD and BC. Now I have to count how many rectangles will be formed, right? Now 1, 2, 3, 4, 5, 6, that is very obvious answer, but you must be clear that this is not correct, because this is also one more rectangle. This is one more rectangle. Similarly, we have this rectangle, we have this rectangle. Then if we match this point, this point, this point and this point, will be getting more rectangles, right? So I cannot keep on counting. Now the same funda I'll apply over here as I applied in the previous question, right? Now in this line there are 4 points. That's 1, 2, 3 and 4, right? See, there were two lines. I draw two parallel lines, so in all there are 4 points. Similarly, on this line there are 3 points, right? So I need to select 2 points from this line. So from 3 I am selecting 2. Simultaneously I have to select 2 points from this line. So from these 4 points I am selecting 2, right? So 3C2 into 4C2, that is 3 into 4 into 3 by 2. So 3 2s are 6, 3s are 18 rectangles will be formed, right? I just give you one example. Suppose I select these 2 points. I just wait a moment. If I select these 2 points from this line, and if I select these maybe 2 points from this line, so what is the rectangle which I'll get is this, this, this and this. This is just one example. A, P, X, Y. I got the rectangle as A, P, X, Y, right? Similarly, I can get other rectangles also. Suppose I select maybe this and this 2 point, and from this line suppose I select this and this 2 points, right? So I just draw the lines and I selected this and this, so this and this. So I got this rectangle, right? So various rectangles I'll be getting. In all I'll be getting 18 rectangles. Now I'm sure the problem will be cleared in your mind, right? Doesn't matter how many lines you are drawing parallel to the given lines, right? You just have to count the vertices. If you are drawing two parallel lines, just add two vertices to them, right? Since here we are having two parallel lines, and counting these two vertices we got the 4 points. Similarly, here I draw the one parallel lines, and counting two vertices I got the 3 vertices, right? So if we are drawing m parallel lines, so the total number of vertices will be m plus 2. Out of these two vertices I need to select 2, okay? And if in this case, if there are maybe n parallel lines are there, so n plus 2 vertices are there, and from these two n plus 2 vertices we need to select 2. So in all we'll be getting these many rectangles or parallelograms, right? Where m and n can be different, as in this case, right? I hope you are clear now. Friends, the same problem or the same concept can be used to find out the total number of squares in a chessboard, right? You try to count on your own. I'll be taking a special session on chessboard in which I'll be describing each and everything about, or we'll be going for a postmortem of chessboard. But before that, you try to find out how many squares or how many rectangles will be there in a chessboard, right? Chessboard of 8 by 8, okay? Obviously 64 is not the correct choice. You just try to find it out using the same concept. Now friends, let's take this problem. This is from the previous year CAT papers. Precisely it's from CAT 2004. N persons stand on a circumference of a circle at distinct points. Each possible pair of persons not standing next to each other sings a 2-minute song, one pair after the other. If the total time taken for singing is 28 minutes, what's the N? Right? That means precisely we have to calculate the number of persons participating in the event. Right? Now there are two things. That 28 minutes was a total time taken and each song took 2 minutes. That means in all 28 by 2, 14 songs were sung. So precisely we can say there were 14 pairs, right? Now this concept is nothing but an application of we calculated the number of diagonals in a polygon. So the same concept we will be using over here, or I can say it's an application of that particular concept, right? Suppose I take example over here. Suppose I have 6 persons, 1 2 3 4 5 6, right? Or they are forming a hexagon, right? Now how many diagonals this hexagon will have? How do we calculate that? See, we make the combination of all the 6 points, right? So if we join 2 points, we will be getting a straight line, right? So total number of straight lines are 62, but every straight line is not the diagonal. Why? Because if we match 2 adjacent points, we won't be getting diagonals, right? So we cannot match adjacent points to get a diagonals, right? That means by matching the adjacent points we get the sides of the polygon, right? So but if we have to calculate the number of diagonals, what we will do, we will deduct the number of sides, right? So it's 6c2, that is all the combination of 2 points minus number of sides, that is 6 sides. So the remaining number is nothing but the number of diagonals in this hexagon, right? So this was just an example and this is just an application. This particular question is an application of this concept, right? Here also everybody is singing song with the other person except with the person who is standing next to him, right? So precisely we have to calculate the number of diagonals with this polygon, and in this case a number of diagonals is given, but we have to find out the sides in the polygon, right? The concept is quite similar. If you just think carefully, you'll come to know, right? Now there are n persons, so how many straight lines can be formed? It's nc2, right? And out of these nc2 we have to deduct the number of sides because they will not form the diagonal, or the persons don't have to sing, right? The persons who are standing next to each other, or the persons who are adjacent to each other, they don't have to make a pair. So in all there are nc2 pair minus n, that is sides, and that's actually 14, right? 28 minutes it took, but the total number of songs were 14. Okay, so nc2 minus n is 14. Now just simplify it. So it's n square minus n minus 2n, so it's minus 3n minus 28 is equal to 0, n minus 7, n plus 4 is equal to 0. That means n is equal to 7. That means if we talk about the polygon, it is a 7-sided polygon or a heptagon, or if we talk about this particular situation, there are 7 persons, right? So a concept that we discussed, this particular question is an application for that concept, and I hope you are clear. It's a really good question and it came in CAT 2004, right? Now one more question from CAT previous year papers. 66 games were played in a tournament where each player played once against the rest. The number of players was. Friends, further, it takes 2 players to make 1 team, right? And 1 team means 1 match, right? So precisely there are 66 games, that means there were 66 teams, right? "66" here I'm talking about teams, not persons, right? Now I suppose n persons are there, right? if each team takes 2%, so how many combinations I'll be getting? That is NC2, right? Each team consists of 2%, so number of teams will be NC2. Now NC2 is what? It's 66, right? Now NC2 is what? N minus 1 by 2, and that is 66, so it's 132, right? Now these are two consecutive numbers and their product is 132, so it's 12 into 11 is 132. That means N is nothing but 12, right? So the number of players were 12. I hope you are clear. Now the next question is the number of all 4-digit numbers that can be formed by using the digits 1, 2, 3, 4 and 5 and which are divisible by 4. Now friends, what's the divisibility test of 4? The last 2 digits should be divisible by 4. So first of all, from these 5 numbers we have to make the various combinations of the digits or numbers which give us the last 2 digits as divisible by 4, right? Suppose example 12, then no other combination from 1, then let's take from 2, so it's 24, right? From 3, 1 is not there, 3, 2, then 5, 2. Then we have 44 as well, because digits can be repeated. Since it's not given there that the digits cannot be repeated, so we can take the repetition of digits as well, right? So in all, these are the combinations where the 2 digits are divisible by 4, right? Now what? These are the last 2 digits. So the remaining 2 digits, because we just have to form the 4-digit numbers, the remaining 2 digits in how many ways we can fill, that we have to calculate, right? So suppose it's this. So the remaining 2 digits, for each place we have 5 choices, that is 1, 2, 3, 4, 5. Any of the number we can fill up. For the second place as well we have 5 choices, and the last 2 places are 1 and 2 only, right? So for each combination we have 25 ways. Okay, 25 numbers when the last 2 digits are 1, 2, 25 numbers when the last 2 digits are 24, 25 numbers with the last 2 digits as 32, 52 and 44. So in all 25, 25, 25, 25, 25. That is 25 into 5. In all, there will be 125 numbers, 125 4-digit numbers which are being formed by using these digits and which are divisible by 4, right? So I hope you are clear. Quite a good problem. Now let's see this problem. Total number of numbers greater than 100 and divisible by 5 that can be formed using the digits 2, 3, 5, 6, no digit being repeated. Now if we don't want the repetition, that means at max 4-digit numbers can be formed, right? And we have to make the number greater than 100, that means 3-digit and 4-digit numbers we have to form. And if the number is divisible by 5, that means among these digits the unit place should be occupied by 5 only, right? So first of all, let's calculate the 3-digit numbers. Now at the units place we have just one choice, that number 5 will be there, right? For these 2 places, since we don't want the repetition, we have to select the number from these 3 digits, right? So 3 digits, from the 3 digits 2 numbers we have to select, and these 2 digits or 2 numbers which we are going to select can be arranged in 2 factorial ways, right? So how many numbers will be there? It's 3c2 into 2 factorial. So precisely it is 3 into 2, 6 numbers. Or since the options are in C and P, so this is what 3c2 into 2 factorial is nothing but 3p2. So this is what the 3-digit numbers, right? Now let's take 4-digit numbers. So the condition will remain same. At the units place we have just one choice, that number 5 should be there. For the remaining places we have 3 numbers and 3 like arrangements, 3 factorial arrangements, right? So we have to select 3 numbers out of 3 and arrangements will be 3 factorial. So precisely it is nothing but 3p3. So it's 3p2 3 digit numbers and 3p3 4 digit numbers. So in all 3p2 plus 3p3 total numbers, right? So 3p2 plus 3p3, this is the correct answer. Now we have been given this option also, this particular option, but if the student forget that the arrangement will be 2 factorial and 3 factorial in these cases, he'll ending up marking with this option and there will be an error, right? You have to be careful that where to arrange, where not to arrange, right? Because if you select 2 numbers, that till here it's just selection. If you select 2 numbers, that is 2 3, so from 2 3 you get a number and from 3 2 you get a number, that is 235 and 325. Both the numbers are different, so we have to count them 2 numbers, right? So if you are not making the arrangement, you are making a mistake. So be very, very careful about it, right? Let's take the next problem. Now friends, let's see this question. This is from CAT 2002. If there are 10 positive real numbers n1 is less than n2 is less than n3 is less than dash 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 till n10, that means there are 10 numbers and they are written in ascending order over here. How many triplets of these numbers n1, n2, n3, n2, n3, n4 can be generated such that in each triplet the first number is always less than the second and the second number is always less than the third? That means n1 is less than n2 is less than n3. That means the 3 numbers are written in descending order, right? So a simple conceptual problem. See, we have to make the triplets and we have to select the 3 numbers from this 10 numbers. So how many ways we can select? 10c3, right? Now we have to make the arrangement where n1 is less than n2, where n2 is less than n3, right? So it's just a single arrangement is possible if we have 3 numbers. Suppose we chose the 3 numbers as 3, 7, 2, right? So in how many ways we can arrange them? So where the numbers are in ascending order, that will be just a single arrangement, that is 2, 3, 7, right? So we got all the combination of 3 numbers from these 10 numbers and there is a single way of arranging these 3 numbers, that is the ascending order, right? So whenever we want to arrange the number in ascending order, it's just a single way, just a single way, right? If the numbers are fixed. So 10c3, the total combinations are there and arrangements will be 1 only. So in all 10c3 is our answer. Now 10 into 9 into 8 by 3 factorial, that is 6, or we can say 3 into 2. So it's 2 4s are and 3 3s are. So 3 4s are 12 into 10. In all there will be 120 sets, or we can say 120 triplets, right? I hope you are clear. Further, we have done good number of problems, in fact difficult one problems in this session. We'll be taking more problems from the previous year CAT papers and previous year like other examination papers. So let's meet in the next session once again. Bye bye.